Hi, I'm Andrew Tan here, and welcome to the first of 16 video clips that I'll be sharing with you on sequence and series. Okay, in this 16 video clips, I've actually subdivided into 4 big components. For the 2.1 to 2.3 video clips, the first 3 video clips, I'm sharing with you a sigma notation. And that will include the questions on how do we actually apply the formulas. And for 2.4 to 2.7, that means the next 4 video clips, I'll be sharing with you this method called the method of difference. And then the third part of my videos, I'll be sharing with you from 2.8 to 2.13, that covers about 5 video clips. I'll be sharing with you arithmetic progression and geometric progression. Okay? And finally, the last 3 video clips, I'll be sharing with you recurrence relation. I think by now all of you have noticed that in this chapter is actually one of the hardest chapters in G.C.E 1 curriculum. So I will try my very best to help you to actually understand all the various concepts. Okay, let's start off with this first video clip that we'll be sharing with you on the introduction to sequences and sigma notation. Now, what are sequences? Okay. A lot of students have problem understanding what is meant by a sequence. Basically, sequence is actually a simple definition, is actually a listing of numbers which has a certain pattern involved in it. For example, based on the handouts that you have printed, you see that I gave you some examples, one of which is a sequence with a general term given by uk equals to the power of k. Now, what does that mean? Okay, this k is actually any integer. So for example, if you have put k equals to 0, use 0, that gives me 2 to the power 0. That is 1. If you put k equals to 1, you get 2 to the power 1, that gives me 2. And you put k equals to 2, you get 2 to the power 2, right? That is 4. So this is what we call a general term of the sequence. You probably have understand that this general term of sequence is very important, because if you know the general term of sequence, you are able to find the specific term. For example, if I want to find the 6th term, I can simply look at this and let k to be 6. Okay? And that gives me 64. Okay? So, how are we able to list down these terms? So in this general term, we can write down the sequence as 1, 2, 2 square, 2 cube, and so on and so forth. If you start your k to be at 0. Of course, if you start your k to be 1, you can start with 2, 2 square, 2 cube, and 2, 4. So you realize that whether you start with k equals 0 or k equals 1 really actually depends on the problem. If the problem wants you to start off with k equals 0, then your first term will be 1. If the question wants you to start off with k equals 1 as the first term, then your first term will be 2. Okay? Let's take a look at the second example of the sequence. The second example I gave you was uk equals to 2k minus 1. This being the general term. If you put k equals to 1, your u1 would have been 2 times 1 minus 1, that gives me 1. And if you put k equal to 2, your u2 would have been 2 times 2 minus 1, that gives me 3. And if you put k equal to 3, your u3 would have been 2 times 3 minus 1, that gives me 5. Now, what do you notice about this pattern? You have 1, 3, 5, 7, 9, and so forth. So we call this sequence of odd numbers. Okay. And this sequence is a very important sequence. So do remember that if you want to generate a sequence of odd numbers, the general term is 2k minus 1, where your k can take value 1, 2, 3, 4, and so on and so forth. But is this the only way to generate a sequence of odd numbers? The answer is no. you can easily create another sequence, say called Vk, to be given by 2k plus 1. If you are starting your k to be 0, followed by 1, followed by 2, and so on and so forth, you notice that V0 equals 1. Okay? If you put 1 inside, you get V1 equals to 3. And you put 2 inside, you get V2 equals to 5, and so on and so forth. It is still a sequence of odd numbers. So whether you choose this being the general term, or you choose this being the general term, it really does not matter. It depends on your own preference. Okay? Let's take a look at the third one. Okay, the third example that I gave to you in the handout is actually the general term being minus 1 to the power of k multiplied by k. Now, this part of the general term is a very, very common one in the A-level syllabus. Okay, what does this give rise to for the sequence? If you take a look at k equals to 1, what happens to the uk? It will be u1 equals negative 1 to the power 1 multiplied by 1. And that gives me negative 1. If you look at k equals to 2, your u2 would have been negative 1 squared multiplied by 2. That gives me 2. And you look at k equals to 3, your u3 would have been negative 1 to the power of 3 multiplied by 3. That gives me negative 3. And how about k equals to 4? Your u4 would be negative 1 to the power of 4 multiplied by 4, and that gives me 4, and so on and so forth. Now, what do you notice about this pattern of numbers? Okay, the numbers 1, 2, 3, and 4. So it's increasing in this order. Okay? Every time increasing by a value of 1. But besides that, you also notice the sign in front of the number. The first term is negative 1, the second term is plus 1, the third term is negative 1, and the fourth one is plus 1 again. So the sign alternates itself. Okay? Now compare this general term with another general term. Suppose I give you uk equals negative 1 to the power of k plus 1 multiplied by k. Now what happens to this one? Okay? Now, based on this being the general term now, what is your u1? You put k equals to 1, your u1 would have been negative 1 to the power of 2 multiplied by 1. So it's 1. Your u2, when putting k equals to 2, will give me negative 1 to the power of 3 times 2. That gives me negative 2. And you put k equals to 3, your u3 would have been negative 1 to the power of 4 multiplied by 3, that gives me 3. And you put k equals to 4, will give me u4 equals to negative 1 to the power of 5 times 4. That gives me negative 4. Now you notice by just changing from negative 1 to the power of k to negative 1 to the power of k plus 1, although the numbers remain unchanged, the sign has changed. Okay? The first term becomes plus 1, the second term becomes negative 1, the third term becomes plus 1, and the fourth term becomes negative 1. So whether you should choose negative 1 to the power k or negative 1 to the power of k plus 1 to generate a sequence with alternating signs. Alternating sign means plus for a minus, plus for a minus, or minus followed by plus, minus followed by plus. It depends on the question. Okay? Now let's take a look at now the second part of the concept in this video clip. Then I'll be going through the sigma notation. Now, what is this sigma notation? Now, sigma notation is actually a shorthand notation to represent the sum. Now, there are two important parts for this sigma notation. The first one is this one. This is what we call the general term. And these two values are what we call the limits of summation. Okay. Now, what does this sigma notation do? This sigma notation is actually a way to represent the sum of terms in the sequence. Okay? For example, if you have the following, say 1 plus 3 plus 5 plus 7 plus 9 all the way until 51. Now it's actually very troublesome to list down all this. So instead of summing up in this manner, showing down all the terms in this manner, we write as a sigma notation here. And recall what is the general term of odd sequence. It will be either 2r minus 1 or 2r plus 1. So in this case, if I choose 2r minus 1, then my initial value would have been r equals to 1. Because you substitute r equals to 1 inside, you obtain 2 times 1 minus 1, that gives me 1. How to get the second term? You just have to put in r equals 2 inside. When you substitute r equals 2 inside, you get 2 times 2 minus 1, that gives me 3. You put r equals 3 inside, you get 2 times 3 minus 1, that gives you 5. And where do we stop? We stop at the point where the last value substitute into the value r gives me 51. And that is, of course, 26. Because 26 multiplied by 2 gives me 52, minus 1, that gives me 51. So this is the first value of r to sub in, and this is the last value of r value to sub in. And between them, okay, they are altogether actually 24 terms between 1 and 26. If you include the 1 and 26, of course, there will be 26 terms. Now, let's show another example. Suppose we have the following, right? 2 plus 2 squared plus 2 cubed plus 2 to the power 4 all the way until 2 to the power 30. Okay. Again, this is another problem listing down all the terms. And you want to sum them up. To sum them up, we can write a sigma notation. Here again. And then we ask ourselves, what is the general term of this sum? You have 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, all the way until 2 to the power 30. So therefore, general term will be 2 to the power r. And how does r varies? R will vary from r equals to 1, because when you substitute r equals 1 into this general term, you get 2 to the power 1. You put r equals 2, you get 2 squared. You put r equals 3, you get 2 cubed. Right? All the way until when r equals to 30. Okay? That will give me 2 to the power 30. Now, is this method, of course, much easier? Okay, though it's something very different for all of you, but it's actually a simpler way of representing a sum. But let us try to understand a little bit more about this sum. Okay, for this FR, it sums from m to n. Now, how many terms are there in this sum? To look at how many terms are there in this sum, we can use the upper limit minus the lower limit plus 1. This will be the number of terms. Okay, let's take an example. Suppose you want to sum up from 3 to 20 of r squared. Okay, if you have to list down, you get 3 squared plus 4 squared plus 5 squared all the way until 19 squared plus 20 squared. Okay, now how many terms are there? You can choose to start counting how many terms, or you can look at this formula. The number of terms would be 20, which is upper limit, minus the lower limit, plus 1. So that gives me 18. Okay? Now we look at some formulas and some rules involved in the sigma notation now. Now, for this first rule, it says the summation r equals to 1 to n, a ur plus b vr, and that gives me a summation ur r equals to 1 to n plus b summation vr r equals to 1 to n. Now, when do we use this formula and what does it mean? Now, this a and b are actually constants. What do I mean by constant? Because it's values that doesn't depend on r. Okay? The only terms that changes is the ur and vr, as r equals to 1, 2, 3, 4, and so on and so forth. So if there are constants involved, you can always take out the constant. Also, if there are sum of two terms, two general terms, you can always split them up. I give an example. Suppose we have summation 3r squared plus 4r. r runs from 1 to n. Now this 3 and 4 will be like a constant. You can split it up in this manner. Okay. Now let's take a look at the second law. The second law says that you sum up ur, r runs from m to n. That gives me the summation of ur, r equals to 1 to n, minus the summation r equals to 1 to m minus 1 ur. Now this one says that if you want to sum up from m to n, it's the same as summing up from the first term to n minus the first to the m minus 1. But why m minus 1? Let's take a numerical example to illustrate. Suppose I want to sum up from the fifth term to the 20th term. That means m equals to 5, that's a starting value, and n equals 20. Now we can choose to instead to sum up from the first term to the 20th term. That means from 1 to 20. But this one includes the first, the second, the third, and the fourth term, which is not needed in this sum. So we have to subtract from the first term to the fourth term. Okay, that will give me the 5th to the 20. And this 4 represents m minus 1 because m is 5. Okay, right? So let me give a numerical example to illustrate this second law. Okay, for this second law, okay, it says that, of course, as I can mention to you already, ur from m to n is summation of ur from 1 to n minus the summation of ur from 1 to m minus 1. Suppose I want to sum up, say, r plus 3, say from r equals to 5 to n. Okay, this n can be any number. If we want to represent using this law, it will be summing up from 1 to n of r plus 3, subtract off r equals to 1 to 4, right? Why 4? Because m is 5, so m minus 1 would have been 4, okay, of r plus 3. But why do people actually use this law? Because most of the formulas that are given to you in the A-level syllabus only allows you to start from 1. So you need to change everything that doesn't start from 1 to things that starts from 1. Now let's take a look at the third law. The third law says that if you sum up a constant a from m to n, okay, that will give me n minus m plus 1 times a. What this third law says is that if you're going to sub in r equals m to a constant, okay, you will still get a. If you sub in m plus 1 into this constant, you will still get a. m plus 2 in the constant, you still get a. And all the way until when you substitute n inside, you will still get A because this A doesn't depend on R. But how many A's have you added? The number of A's that you added depends on the number of terms in this sigma notation. And earlier on, I already told you that the number of terms in this sigma notation is n minus m plus 1. Upper limit minus the lower limit plus 1. So therefore, the number of terms here is n minus m plus 1, and the sum would have been the number of terms multiplied by the constant A. Okay? Let's take a look at the three other laws, the last three. Okay, so let's look at this one. R is 1 to n equals to n over 2, 1 plus n. Now, in this law, it allows us to find summation of R from 1 to n. But besides allowing us to find summation of R, it also allows us to find things like this. 3R from R equals to 4 to n, for example. You can always write as a summation of 3R, R equals to 1 to n, minus the summation of 3R from R equals to 1 to 3. And this 3R, you can always take the 3 out. And for this one, of course, same thing, right? Okay. So from 1 to n of R, you can apply this formula by leaving it as n. How about this one? If you want to sum up from 1 to 3, you can choose to put in n to be 3. So you have it as 3 over 2, 1 plus 3. So that gives me 3n over 2 into 1 plus n minus 9 over 2 multiplied by 4. So that gives me 3n over 2, 1 plus n minus 18. Okay. So this formula will allow you to find expressions of this nature. Now let's take a look at the second last law, which says that summation of R squared from 1 to n gives me n plus 1, 2n plus 1 over 6, as well as the summation of R cubed being the last law, which says from 1 to n of R cubed, that gives me n squared, n plus 1 squared over 4. Now you do not need to memorize these two formulas because both formulas will be given in the question itself in your A-level syllabus. But you really need to know how to apply it. For example, if you want to find summation of 3R cubed plus 2R squared plus 5R minus 1, for example. Okay? You need to know how to split it up in this form. Okay, so for the first one, you can then apply this formula to substitute inside. For the second one, you can apply this second formula, substitute inside. And for the third one, you can apply this formula inside. And for the last one, remember the constant formula. You can also use the constant formula. To apply. Except that your m in this case will be 1 and your a in this case is also 1. Okay, so that will actually go through the introduction to the sigma notation. Okay, thank you.